So I'm Tim Joyce. I'm from ST Bristol, Microelectronics. I'm the verification manager at that site. And we are making SoC products for the set-top box and the home media gateway markets. And we tend to have products in the complexity from about 100 to 500 million transistors, so fairly large SoCs. And we're one of 4 such SoC teams in the world for ST, other ones in France, India, and the USA. And we've got a team of 20 people who will take, not just verification, who will take the entire SoC from conception through to production. So my first challenge that we face on a day-to-day basis is just the sheer complexity of the SoC simulation environment. And there's 2 threads to this, really. First of all, the IP count in our SoCs is ever increasing. It's not just the IPs. There's a couple of examples here of some recent projects, 2 different sizes, but the first project had 59 IPs, 71 functional clocks, and only 4 CPUs. Second project was pretty much double the size in terms of IPs, and in functional clocks, 13 CPUs. Same test on both of those projects, 1.7 times slower on that second larger project. So what we're really seeing is that the scalability of our simulations is going to hit your regression time, and you have to start being clever. So you'll try and take out the C model from running on in RTL, or from even running in embedded C. Take that out, make it run on the Linux server. You get about a 5 times speed up for that methodology. Very useful. You still need to do some more. Turn off some functional clocks for blocks that you're not actually using, and then even take bits out of the design, black box some things. That's still quite challenging to do. And again, emulation, bringing emulation earlier in the project. We've seen a couple of previous speakers saying emulation very important, very true. You can't do a huge amount up front. The second thread to this is that the number of external interfaces to your SoC increases as well. That means your test bench gets much more complex. You've got VIPs for DDRs, flash memories, SATA, PCI. Those 2 previous projects, we had 19 test bench model instances in the first project, 33 in the second. It all adds to complexity. And your simulation snapshot still has to be built. Then you've got multi-language, Verilog, VHDL, you've got system C, you've got system Verilog in there as well. You might have some spec man. You want to implement it for coverage. You've got to link it, run it. Different versions of GCC, Perl come in. That really can be challenging. And then you want to do low power verification? Fine, add it all on top of that. It's a big challenge. So my second challenge really, again, we've heard it before, but how do you know when you're done? When you run all the tests that you've identified, they might be tests that have been given to you from your SoC, from your IP providers, there might be ones you've reused from previous projects. There might be specific directed ones for particular functionality you want to prove on that chip. But when you run all those, what's left? So something we've found that we actually want to use toggle coverage. So of the integration nets, when you've got your IPs, you're doing integration verification. So that was I think the third step that Mark Owen pointed out on the 4 stages. You actually want to make sure that you've covered all those points. So one thing we actually do is to collect a database of that. And because you might be running your tests around the world, you actually need to implement some form of coverage database that allows you to identify what has actually been covered, what hasn't been covered. And then it's very manual task to analyze all those different coverage points that you've got. You're going to have to exclude some. Some might be DFT, things that you're not worried about. Some of them might be just completely non-functional. They might be completely irrelevant. Go through manually. You have to exclude all of those points that you're not worried about. But then that's very manual. You've done that, and you want to reuse that for the next project. So we have a database system that a colleague in my team did the coding for that allows us with a visual basic front end remote database to make that work. But if you've excluded it on one point of those nets, my challenge to the EDA companies is I actually want to automatically exclude that on the other points of that net. I don't want to have to go around and find, oh yes, it was connected to another point somewhere across the design. Automatic exclusion and reuse. And my top challenge, as I'm sure everyone has a very similar problem, is resourcing. Verification, as we've heard, is an increasing amount of project time. One-to-one for designers, the verification, yeah, I'd be lucky to get one-to-one. You always need more resource. It takes time. It's peaky, sure. But one thing I'm doing here is just looking at previous results. So color graphs, but we have the green is your pass rate on the total number of tests. And we've got 3 different projects here. So my top right one is a slightly small, it's actually project A from the previous slides. We've got about 600 functional tests. And we're looking over time of how that progression of the passes, the purple is tests you've yet to complete, of how that evolves, and something comes out. You can actually look and see it's fairly predictable. As long as you know how many resources you've put in to get to that point, it's predictable. You'll get a different progress rate for a different type of project. So the graph on the bottom left is for actually it's a respin of a product. So it would get to a higher completion rate a little bit faster. But if you look at that, you can then decide, okay, I can work out how many people I need. Let's see how we can do it. Okay, so as I mentioned, we've got 3 other teams around the world. They might be working on their own projects. You might not be able to use those. We've used them previously, perhaps not this time. And one of the things that we've done for this particular project that was to actually use contracting, SOC contracting verification engineers. We'd never used that in an ST before. No one knew if it could actually be effective to do that. So we worked with a company to provide those contracting engineers, and you can see the inflection point on this graph here. So at this point here, we added a team of engineers. We actually added 12 engineers to be able to hit our deadline, and we'd worked out the number we needed, and the answer is yes, it is actually possible to do. Okay, the engineers might not be working the way you would normally have them working in your environment. It is possible. You can take a 2 or 3 month hit to get to full effectiveness, the same as working for one of your team members. It can be done. My final challenge is that some of you may know the ST Bristol site is closing at the end of Q1 next year. So a new challenge awaits for not just myself, but it's also on the site, 150 people on the site. All jobs are lost. My CV might be available.
It reminds me of Joyce Hughes. I have one very quick question, probably an obvious question for Tim. What was the company you used for the SOC verification?
We did use TVS, and other companies may be available.
Other companies are available. So, is there any serious questions for Tim? Sorry.
So what in terms of final quality within these 2 projects, do you think they are comparable? Did you reach the same level of quality? We
did reach the same level of quality. In fact, using the exclude methodology where you can get to a percentage of total coverage, in both of those projects, we did actually get to 100%, I'll say justified nets. Your managers will always ask, what do you mean by that? But you justified and you've seen. And it's a really, really useful technique to do. Very manual, but yeah, we got what we wanted.
Any more questions for Tim? Okay. Well,
I think I recognise Will.
Hi, Tim. So in your graph, all your graphs, the number of tests went down at some point, usually later on.
Yeah, it's interesting, isn't it?
Where did they go?
Normally what happens is you'll start from a projection of what you think you're going to do. So you'll get a test, like a little list of IPs from your project leader, and will say, okay, this is what we've got, this is the new part of IPs. And you go back and say, oh, I've used that one on that project, that one and that. So you go through and you take all the number of tests you had on the previous project, put them into your test plan, and you think, I think that's pretty much what they mean. And then the marketeers come along and say, yeah, we actually want to add an extra PCI Express, or we want to do this or do that. And you might have a new block. You might not know how many tests the IP provider might give you. So I put in perhaps 10 tests for a particular, but that will come down, it iterates down, and then we end up. So that total does level off, get closer and closer, and then you might have seen a lighter green pass rate. And that drops when you get a new release of the SoC, and you get regression failures you've got to then tweak up, but most of them are usually your test benches has been modified something. But yeah, it's iterative, but it's very interesting data. I recommend everyone goes back and looks at their history, as long as you're recording it. But it's I can also look at projects from India, from global. I can cheat and spy on other people's projects. It's worth doing.
Any more? Okay, thank you very much, Tim.